Hi, everybody. This is Professor Monty. Today, what we're going to talk about is the difference between inductive reasoning and deductive reasoning. So you can see I've written on the board. Inductive reasoning, the process of arriving at a general conclusion based on observations of specific examples. And so it's something that makes sense to us, something that we've seen, something we've looked at. For instance, I may say, hey, you know what? Every time I've played the lottery, I've lost. Don't waste your time. Don't waste your money playing the lottery. But of course, that's not necessarily true. For the vast majority of people, of course, it is true. But what do you have to find to disprove what I've just said? All you have to find, of course, is just one person that's won the lottery. And you can say, hey, your reasoning, your inductive reasoning didn't work out. Maybe it's worked out for you, maybe it'll work out for me and most, if not everybody I know. But it doesn't always work out because some people do win the lottery. And so in fact, inductive reasoning can come to wrong conclusions. And all we need to find to disprove something that we've reasoned inductively is a counterexample. And so the person winning the lottery was the counterexample to what my statement was that nobody wins the lottery. Okay, so that's inductive reasoning. We can compare that to deductive reasoning, the process of proving a specific conclusion from one or more general statements. A conclusion that is proved to be true by deduction is called a theorem. So let's kind of back up a little and we'll see the difference between these two. So we already saw an inductive reasoning argument that can be disproven with a counterexample. Well, deductive reasoning can't be disproven if we've reached the conclusion accurately. Let me show you kind of an example to bridge the two. So say I've got this sequence of numbers. Let's go 4, 7, 10, 13. And what I'm trying to do is predict what the next number is. Well, inductively, I can look and I can say, well, is there a pattern to this? What's going on? And I can say, oh, look, it looks like if I just add 3, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. I'm guessing I just add 3 again. And so 13 plus 3 is 16. That's going to be my next number. And in fact, that is my next number. But I've done that inductively. I've looked for a pattern. I've tried to figure out what it might be. If I can actually find a formula for this, then it would be deductive reasoning. I've proven that that's what it has to be. And in fact, I can prove that. We can look at this. And if I write this general formula A sub n, which says, okay, n is going to be the number of terms, so like the first term, second term, third term. This would be A sub 3 because it's the third term. I can get a formula for this, which is actually the formula is going to be 3 times n, whatever the term number is, plus 1. And we can check that because for the first term, I'd put a 1 in parentheses. 3 times 1 is 3, plus 1 is 4. Well, let's check this 1, 2, 3 for the fifth term. 3 times 5 is 15, plus 1 is 16. That actually is the formula for it. So now, deductively, I've shown that's true. We will see this sort of thing later when we do sequences and series. But inductive reasoning is just kind of figuring out, looking for a pattern, figuring out what it probably is. Deductive reasoning would say, hey, look, I've got a formula. It has to be that, it can't be anything else. And I can use whatever term number these are to find all these numbers using that formula. So one more quick example of deductive reasoning that's away from like a formula. Say we say something like this, and I'm just going to speak it instead of writing it out. But say we say something along the lines of, all puppies are dogs. Milo is a puppy. Therefore, Milo's a dog. So we can actually just, really write that out quickly. This is a deductive argument. So we can say all puppies are dogs. And if we accept this to be true, that's our first step. And then we say, oh, Milo is a puppy. And if we accept that, then we have to accept the conclusion, those three dots in a triangle mean therefore. Therefore what? Well, if Milo's a puppy and all puppies are dogs, Milo must be a puppy. Therefore, Milo, that is a puppy, is a dog because he's a puppy, but puppies are dogs. So Milo is a dog. If we accept these two statements, this follows logically, that would be a deductive reasoned argument. And I know I have it under inductive, but it's where we had deductive before. So anyway, that's the difference. Inductive reasoning, we go to a general thought. The conclusion, sometimes you call it a theorem, a hypothesis, sometimes not a theorem, a hypothesis, a conjecture, something like that. It may be incorrect at times. It's not 100% accurate. Deductive reasoning has to be 100% accurate. You cannot disprove a deductive argument if you go with two basic premises, or however many we have. If those follow, if those are true, the conclusion had to be true. That would be deductive. Okay, so work with some of these, practice them. Inductive might be wrong, at least in some cases. Using a counterexample we can show. Deductive arguing, if we do a deductive argument properly, it can never be incorrect. All right, work with these, have fun, and we'll look at some more things pretty soon.